Hello, dear students. Today we are going to study the second topics. In the topics, we here are going to study the relationship between the zeros and the coefficient of the given polynomials. Relationship between zeros and coefficient of given polynomial. Dear students, you see here the first in the previous classes we have studied the types of polynomials on the basis of the terms and also studied the polynomials on the basis of the degree. Here on the basis of the degree, we can take one examples here. First, linear polynomial. Then what is the general form of linear polynomials? Linear polynomials. When the degree of the polynomial is 1, then the polynomial is called linear polynomials. Here, example 2x minus 6 is equal to 0. This is the linear polynomials and p of x. Let this p of x is equal to 2x minus 6 is equal to 0. 2x minus 6, and in this we can find the 0. In linear polynomials we find the 1 0. In quadratic polynomials we find the 2 zeros. Why? Because on their degree is 1, therefore the solution and the roots of the polynomial is 1. In quadratic polynomials there is 2 zeros. First of all, we will consider this one. We know that the general form of the ax plus b, ax plus b is equal to 0, or this polynomial is known as the general form of linear polynomials. Now see here, we find the 2x minus 6 is equal to 0. By taking minus 6 that side, 2x is equal to 6 and x is equal to 6 by 2 and x is equal to 3. We get the one solution here with the root of the polynomial here, that is 3. This 3 is called the zero of the given polynomials. We know that in this general form, of the polynomial, that is ax plus b, but the root or the zeros of the polynomial is equal to their ratios of their coefficients. What are the ratios of the coefficients? We can see here the 0 is equal to 0 of the given polynomial is equal to their ratios of the coefficient, that is b by a, that is minus of b by a. What is minus b? B is the here coefficient and a is the coefficient of x. B is the constant of where a is not is equal to 0 here. Oh dear student, here constant term, suppose b is the constant term, minus of constant term divided by coefficient of x. See here, the zeros of polynomial is equal to the ratios of the coefficient of the given polynomial. That is, we see here, I already know that x is equal to 2x minus 6 is equal to 0. 2x is equal to 6 and x is equal to 3. The zeros of the polynomial is 3 here, and we verify here that minus of b by a. Minus of b is here minus 6, minus and minus of 6, that is divided by the 2. Here we get 6 by 2, that is equal to 3. We observe that the zero of the polynomial is equal to the relation of the coefficients. Therefore, we can verify here the zeros of the polynomial is equal to their relation of the coefficient. Next, we will take another example, that is x square plus 2x 3x plus 2. This let p of x is equal to x square plus dx plus 2. Then the general form of quadratic polynomial, that is a square plus bx plus c is equal to 0. Here a is the coefficient of x square and b is the coefficient of x and c is the constant term here. You see here, first of all, we will find out the zeros of the given polynomial. Here you see x square plus 3x 2 is the given polynomials. Here 3x can be split, that is 2 and 1. Why? Because the sum should be 3 and the product should be 2. Here, when we multiply this number 2 into 1, that is 2, and when we add this number, we get 3. Therefore, the required number, required factor, that is x, 1 and 2. Therefore, we can write this by splitting the middle term, that is 2x plus 1x plus 2. When we are taking the common from these two terms, we get x in bracket x plus 2. In another two terms, we can take 1 as a common, x plus 2. Therefore, we get here, they are the common, and x plus 1 and x plus 2 is equal to 0. Dear student, when we compare the both factors with 0, then we get that either x plus 1 is equal to 0 or x plus 2 is equal to 0. Here x, by transposing one that side, we get x is equal to, or x is equal to minus 2 here. Both of the zeros are minus 1 and minus 2 here. Dear student, you see the zeros of the given polynomial, that is minus 1 and minus 2. In this, we have to check, or we have to verify that whether the sum of the zeros, the sum of zeros, what are the zeros here? Minus 1 and minus 2. Therefore, the sum of the minus 1 plus minus 2 that is equal to minus 3 here. We can check the relation of the coefficient. Coefficient here you see our polynomial is x square plus 3x plus 2 that is equal to 0. Here 2 is constant, 3 is the coefficient of x and 1 is coefficient of x square. Therefore, we can write here the coefficient of x minus of coefficient of x divided by coefficient of x square, coefficient of x square. When we check this coefficient of x is 3 here, minus of 3, then 1, we get minus 3. We observe that the sum of the zeros and the coefficient relation of the coefficient, they are equal. Therefore, it is verified. We can further verify that the product of the two zeros. What is product of the two zeros? We already know that the product of the zeros. The product of zeros, that is equal to minus 2 minus 1, that is equal to 2. The product here we get is, that is positive 2. When we observe this, you see here the constant term is, here we can take the constant term divided by coefficient of x square, that is c by a. We can write it as c by a. This will get, the constant term is here 2 and the coefficient of x square is 1. The answer we get, that is 2. Therefore, the product of the two zeros and the relation of the coefficient, they are equal, and it is verified here. So dear student, I hope this is very clear to you, and such type of polynomials, using such type of polynomials, you can find out the zeros of the polynomials and verify the relationship with the coefficient of the given polynomial. Thank you.